So now we're gonna determine the chirality of this entire molecule.
Okay.
Do you remember how to determine
Oh,
if
assigning RNS.
a carbon is a chiral center? So you would
Oh,
assign R
yes.
and S if there is a chiral center, right? So if
Right.
there's
So
a chiral center,
if it has
uh-huh,
a, I think four,
yep,
four. Okay.
four different
Okay.
groups
Yeah.
attached to it, right? So if we look at this carbon here specifically,
Mm-hmm.
that is a chiral center because it has a bromine, a benzene, this whole big bulky R group, and an invisible hydrogen right there.
Mm-hmm.
Right? So that's a chiral center. So I'm gonna star that here. This is also a chiral center right there, right? But even though a molecule has chiral centers, it does not mean that it is chiral, right? Because can you remember what factor would make it achiral, like the entire molecule achiral, even though it has chiral centers?
If it's meso,
Meso, right? Which has a plane of
symmetry.
symmetry. Yes, plane of symmetry. And in this case right here, we cannot clearly see the plane of symmetry. What we have to do is we have to
Eight.
rotate this sigma bond or single bond
Okay.
to show our plane of symmetry very clearly, right? This is the bond right here that I'm rotating. I'm keeping everything on the left side the same. And I'm just gonna flip the benzene and bromine around where the benzene is now gonna be down here and the bromine is going to be up here. But when I do that, I'm inverting this dash bond right here that we see into a wedge bond
Okay.
like that. And because of that, we can now clearly see the plane of symmetry down that middle line right there. Everything on this side is the same thing as this side right there. Plane of symmetry. So because of that plane of symmetry, this is meso, aka a chiral. Right. Now, would this molecule be considered meso or achiral?
Um, yes, if you rotate it. But no, it wouldn't, because then that would change the stereochemistry
Yes,
if you
it wouldn't.
rotate it.
Right.
But it does have a chiral center, does it not?
It does have a chiral center here and here, two chiral centers specifically.
Mm-hmm.
But when we do rotate it, like you said, it's going to flip the stereochemistry from a wedge to a dash. And those two chiral centers are still there. Nothing changes about those chiral centers. But we do not have a plane of symmetry at all. So this entire molecule is considered chiral. It's not meso, but it's chiral.
Okay.
Right.
Got
Whereas this molecule here is achiral because it has that plane of symmetry making it meso.
Okay.